If you have ever stared down a board full of calculus and felt your stomach drop, you aren't alone. Without context, these equations look less like a subject to learn and more like a hostile alien language. Most of us grow up assuming math is a cultural tool we invented from scratch, like the wheel or the alphabet. Under that assumption, the struggle to learn it feels like a natural response to an artificial system. But if mathematics is purely artificial, a set of arbitrary rules we made to organize society, we have to explain how it maps onto reality so perfectly. We use these exact mathematical principles to plot the precise orbit of distant stars and trace the physical architecture of the cosmos. We engineer machines, like the early Cray 1 supercomputer, using this same language to process data on a scale our conscious minds can rarely even comprehend. This forces us to ask a different question. What if our fundamental relationship with mathematics is backwards? What if mathematics isn't just a tool we invented, but a physical sense we are actually born with? Evolutionary biologists call this physical baseline number sense. The data shows it is present the exact moment you enter the world. Cognitive studies show that 6-month-old babies, before they can even speak, can look at a screen of multiplying shapes and recognize the difference between varying quantities. We share this hardware with other species. Crows, monkeys, and wolves use rapid quantity recognition to track predators and locate food. We know exactly where this hardware lives, deep in the human brain, in a fold called the intraparietal sulcus. But there's a catch. This region evolved purely for rapid, rough estimations, like assessing which bush has more berries, or which bird flock is larger. You do not start as a blank slate. You arrive pre-wired with the foundational hardware to process quantities. So, if our biological hardware caps out at rough estimations, how do we jump from counting berries to executing infinite calculus? The answer is a neurological hack. The brain builds a bridge connecting the parietal lobe's raw processing power directly to our highly evolved visual and language centers. To cross it, humans invented symbolic language, giving abstract ideas physical shapes like numbers, plus and minus signs. By translating rough estimations into exact visual symbols, we lock specific variables into place. This allows us to manipulate quantities that are far too large for our biology to hold in its working memory all at once. Advanced mathematics is the direct result of using a cultural invention to stretch our innate biological hardware to its absolute limit. Mathematics is a biological capability, amplified by a cultural tool. This biological reality challenges the concept of the math person. Barring specific neurological conditions like dyscalculia, virtually every single human brain sitting in a classroom possesses this exact same mathematical baseline. For many, the friction of math anxiety starts at this neural intersection, where the brain works to translate these cultural symbols back into its native biological language. Your innate ability to understand the world through numbers is a birthright, hardwired into your skull before you ever stepped into a classroom.